Hi, I am Dr. Eli Kohlberg from Unlimited Robotics. In this video, I will talk about magnetic field, and it will be the second part out of two parts. Physical proximity, meaning how close or far away, really counts in magnetism. The closer you stand to a magnet, the stronger the magnetic field will be. The further away you are from a magnet, the weaker the magnetic field becomes. A magnetic field never ends, it simply gets weaker and weaker the further away you go, in principle even to infinity. The direction of the magnetic field caused by a moving charge, meaning a current, can be found by using the right hand grip rule. Curl the fingers of your right hand up, stick your thumb out and position your hand so that the direction of your thumb is in the direction of the current. Conventional current flowing from plus to minus. Then the magnetic field acts around the current in the direction of your curled fingers as presented in next figure. The strength of the magnetic field at a point in space is called the magnetic flux density, B, and is measured in Tesla, T. Pay attention that we are talking about density, which means amount of lines in a specific area. In electric fields, we take the field's direction to be the direction of the force on a positive charge. Similarly, the direction of the magnetic flux density is the direction of the force on an isolated north pole. The magnitude of the force on a wire carrying current I with length L in a magnetic field is given by the equation F equals I times L times B times sine theta, where F is the magnetic force, I is the current, L is the wire length, B is the magnetic flux density, and theta is the angle between the wire and the magnetic field. The force is perpendicular to the field and the current. The equivalent formula for the force on a moving charged particle of charge Q and velocity v is F equal Q times V times B times sine theta. The force is perpendicular to the field and to the velocity. If a magnetic field is viewed in terms of field lines, then the magnetic flux density at a point can be thought of as how close the lines are together. That is the number of lines which cross each unit area. The total magnetic field, the number of lines, is called the magnetic flux phi and is measured in Weber. We designate it with letters W, B. It follows that 1 Weber equals 1 Tesla times square meter, and that phi equals B times A, where A is the area through which the field lines pass and is measured at right angle to the field. Where the magnetic flux phi passes through a coil of wire with N turns, we define the magnetic flux linkage to be N times phi. Now, quiz. Unit of magnetic field is Weber, Tesla, Newton, or watts? The answer is Tesla. Magnetic fields are represented by magnetic field lines, electric field lines, straight lines, or none of the options. The answer is magnetic field lines. Magnetic field is stronger and crowded in the region away from the magnet, the region around from the magnet, center of the magnet, or near the poles. Answer: near the poles. Magnetic field lines always make circles, parallel lines, straight lines, closed loops. The answer is closed loops. Magnetic field arises when a charge is in motion, when a charge remains stationary, when charge interacts with electric field, when charge is far away from another charge. The answer is when a charge is in motion. What does a current carrying wire perpendicular to a magnetic field experience? An increase in voltage, a force on the wire, an increase in current, or the reversal of the current. The answer is a force on the wire. Which direction is the magnetic field pointing at location 2? Up, down, out of the screen, or into the screen? The answer is into the screen. That's it for now. Thank you very much for being with me. I hope to see you in the next one. Bye bye.